Continuing with multiplying polynomials. When we see a term outside of parentheses, we need to remind ourselves that that entire term needs to be distributed over every piece inside the parentheses. So we would do that here, we would also do that here, and we would also do that 3 times down here. Every time I distribute, I always write these arcs or even arrows underneath or above what I'm doing just to keep myself organized. It's a very common mistake for students to only multiply the outside term times the first term and just leave the second term the way it is, and that's a big mistake. So a good way to stay ahead of that is to use arcs like this. So I would take 5a times negative 12a, and using the same process before, I would take 5 times negative 12 times a to get that result. 5 times negative 12 would be negative 60, and a times a would be a squared. For the next piece, I would take 5 times negative 6 times a. Again, I'm going to handle the coefficient and the constant first, and then the exponent. 5 times negative 6 is negative 30, and times a would just be a. So this whole expression just simplifies to negative 60a squared, 5a times negative 12a, and 5a times negative 6 simplifies to negative 30a. Likewise here, I'm going to handle the coefficients in the first term and the first term inside the parentheses before I move on to the variable. So I'll take 4 times negative 7, and then I'll multiply the x to the third that is outside times the x that is inside. 4 times negative 7 would be negative 28. X to the third times x to the first would be x to the 3 plus 1, or x to the fourth. And now I would take 4 times 1 times x to the third. 4 times 1 is 4, and it's positive, so that would be positive 4x to the third. Again, all I'm doing is distributing the entire term over each term inside, keeping track of my signs, and making sure that I stay organized when I do that work. Down here, it looks a little more complicated because now I have 2 different variables raised to different powers, and there are 3 terms in the polynomial. It's a trinomial inside the parentheses. The process does not change. We're going to take 3, again, a coefficient here is 1, so I don't need to include it, times a, again, I'm going to handle the variables in alphabetical order, times b to the 7th times b to the 3rd. So that first term would simplify to 3a squared b to the 10th after I distributed this times this. Now I will distribute 3ab to the 7th times the negative 12b. That would be 3 times negative 12. Handle the coefficients first. I have an a outside, and I'm not multiplied by any a's here, so now I can move along to the b's. b to the 7th times b to the 2nd power. 3 times negative 12 is negative 36. The a remains, and now I can combine the exponents in my b's. So b to the 7th times b to the 2nd would be b to the 9th. Finally, I'm going to distribute this outside term, 3ab to the 7th power, times the positive 4a. I'm going to handle the coefficients first. So 3 times 4 times the a that's here, and I have an a that's here, and I have still the b to the 7th power outside. So 3 times 4 is 12. A times a would be a squared, and then the b to the 7th remains. I'm not finished until I unite all these into one large polynomial, and that would look like 3a squared b to the 10th minus 36ab to the 9th. This 12 is positive, so that would be plus 12a squared b to the 7th power.